So when you have two wires right beside each other, straight wires, and you send a current through both of them in the same direction, this is going to be a pretty strong current here. You may find that they will either attract or repel each other. Well, we're going to figure out which one it's going to do. And that's actually going to be based on two right-hand rules, which are shown on the right there. Right-hand rule number one talks about how a single wire can create a magnetic field around it. And right-hand rule 3 talks about how a moving charge experiences a force when it's inside of a magnetic field. Well, what is current through a wire? All it is millions and billions of moving charges in the wire. So all those charges are going to feel a force. So the entire wire might feel a force. Okay, so I've numbered these wires 1 and 2. This is going to require multiple colors to explain this properly, the best way I know how. So I'm going to start with the color blue here. And blue is going to represent the magnetic field created by wire number 1. Okay, so I'm going to focus on wire number 1 first. I'm going to apply right-hand rule number 1 to wire number 1. So I'm going to stick my thumb in the direction of wire 1, and I have to visualize my other 4 fingers wrapping around that wire, creating circular magnetic field loops around that wire. And I'm not going to draw the entire loops, but what I'm going to draw is which way the magnetic field is going when it hits the other wire. So if you look at the picture on the right here, this loop, when it hits the position of the other wire, wire number 2, it looks like the magnetic field is actually going into the page at that point. And it's going to do that all along the wire. So what I'm drawing right now is the magnetic field loops created by wire number 1. I'm just going to draw it on the other side as well. It would be coming out of the page on the other side of the wire. So like over here, it's coming out of the page on that side. All right, so that's the magnetic field created by wire number 1. And I only drew the portion I care about, the portion that's hitting wire number 2. So this magnetic field that's hitting wire number 2, that's actually going to apply a force on wire number 2 based on right-hand rule number 3. So for wire number 2, if I put my hand in right-hand rule number 3 position, I would stick my middle finger, because the middle finger is the magnetic field, I would stick my middle finger into the page. I would stick my index finger up. So the velocity of the charges would be the direction of the conventional current, which is up. So I got my middle finger into the page. I got my index finger up. And then I ask myself, when I stick my thumb out at a 90-degree angle to both of my other 2 fingers, which way is my thumb pointing? And I'll find that my thumb points to the left. My thumb points to the left, meaning that wire number 2 will experience a force to the left. All right, so that's half the story. We can apply the exact same argument, but we're just reverse the roles of the wire. So now I'm going to use green. And I'll say green is the magnetic field created by the other wire, wire number 2. So I go back to right-hand rule number 1, but this time I apply it to wire number 2. So I stick my thumb up and visualize my fingers wrapping around wire number 2. And when I do that, I'll find that its magnetic field comes out of the page on this side, and my fingers would loop back around and go into the page on the other side. Okay, so these green circles, that represents the magnetic field created by wire number 2. So I really only care about the section that's actually touching wire number 1. And now I'm going to apply right-hand rule number 3 to wire number 1. So again, my current is going up, and the current is going to be the index finger. That's the velocity that the charges are moving, the direction of their velocity. And my middle finger is going to be out of the page this time, because that's the magnetic field. So if I got my index finger up, my middle finger out of the page, and I make my thumb stick out at a 90-degree angle to both of them, my thumb ends up sticking out to the right. So wire number 1 feels a force to the right. So let me write out the explanation. So this is part of the explanation. The blue field is the field created by 1, green is created by 2, but I want to add that these are due to right-hand rule number 1. It's important that you identify how you figure that out, and you quote which rule you used. So then continuing from there, each wire carrying a current will feel a force from the magnetic field created by the other wire. And the direction will be based on right-hand rule 3. I'll say as shown, because I kind of drew in the diagrams there. I put in brackets which fingers are pointing which way, so I kind of try to show it on the diagram there. The wires attract. The forces are towards each other, so the wires attract. So another way to do this, to save a little bit of time, is you don't actually have to do the analysis for both wires. I did the analysis for both wires, but once you have the analysis done for one wire, you could actually go back to Newton's third law and say that the reaction force has to be equal and opposite. That'll save you time, but either way it works. So these two wires attract, and you'll find that if the currents are in opposite directions, the wires will repel. And there's a video demonstration by some MIT lab techs there that clearly shows the two wires either attracting or repelling depending on the directions of the current.